Math Blast 14. I can identify prime and composite numbers. Look at the numbers below. Shade each number that is prime. A prime number is a number that has exactly two factors, 1 and the number itself. So looking at 36, I know that 1 and 36 are factors of 36. If those were the only two factors, that number would be prime. If I can find at least a third factor, then we have proven that the number is no longer prime but must be considered composite. So, since this is an even number, I know that 2 would also be a factor of 36, making it a composite number. 15, 1 and 15 are factors, but so is 5. Any number that ends in 5 or 0 has 5 as a factor. So there we've proven a third factor, making that a composite number. 2, 1 and 2 are factors of 2, and those are the only two factors of 2, so I will shade the box, recognizing it as a prime number. 9, 1 and 9 are factors, but so is 3. 3 times 3 gives me 9, so that's a composite number. 17, 1 and 17 are the only two factors of 17. Therefore, 17 is going to be a prime number. I shade the box. 25, 1 and 25 are factors of 25. Again, this number ends in a 5, so we know that 5 is also another factor of 25, making it a composite number. Fill in the chart below with 4 different composite numbers that are between 40 and 50. I can put any even numbers between 40 and 50 in those boxes. I could also put 45 because, as I stated up above, any number that ends in 5 is going to be a composite number as well. So I'm going to go with 42, 44, I'm going to say 45, and then the next even number there, 46. Again, those are not the only choices you could put there. Those are just some of the ones that I know for sure are composite numbers and I'm going to use for this round. I can divide a 4-digit by 1-digit number. Solve using any method. 2,324 divided by 7. Here I'm going to use the box method. I'm going to put 2,324 in my box and I'm going to divide by 7. So I'm going to ask myself, how many groups of 7 do I want to pull out of that box without going over 2,324? I know 1 7 is 7, definitely not enough. 10 sevens is 70. 100 sevens is 700. 1,000 sevens is 7,000. So it's going to be in the hundreds. Well, again, I said 100 sevens is 700, so I could subtract that. I have 4, 2, here's 13, and this becomes a 1. We get 6 and 1. 1,624 is what's left in my box. Now I know last time I took 100 groups of 7 out, which was 700. So if I take 200 groups of 7, that's going to be double the 700, which is 1,400. I'm going to subtract that, and I'm left with 224. That's what will go in my new box. Now, I know I don't have enough to pull out another 100 groups of 7, but I do have enough to pull out 10 groups of 7. That would be 70. So I'm going to pull out 30 groups of 7. 3 groups of 7 is 21. So 30 groups of 7 is 21 tens. I'm going to subtract that, and I'm left with 14. I know that 2 groups of 7 gives me 14. So I can subtract that, and I'm left with nothing. Now I can add all these parts to the quotient that I came up with. And we may have different numbers up there because you may have chosen to pull out different amounts of 7. As long as in the end we end up with the same answer. So we're going to have 332. 332 is the quotient, the answer to our division problem. Now, last box here for the front side. I can add and subtract fractions. Add and show your work. 3/6 plus 4/6. Well, I'm going to draw a fraction bar here, and I'm going to break that into sixths. I want to shade in 3/6. 1, 2, 3/6. Now I'm going to add on 4/6. So here's 1, 2, 3. Oh, I don't have enough, so I need another fraction bar. We'll break that into sixths. And I needed one more. So here I had my 3/6. 1, 2, 3/6. And then I added on 4 more sixths, which is 7/6. Or we can see that is the same thing as 1 whole and 1/6 more. Subtract. Show your work. 9/10 minus 6/10. So we'll start with a fraction bar, and this time the units we're dealing with are tenths. So I'm going to break my fraction bar into 10 equal parts. We want 9/10. I'll shade in 9 of the tenths there. And now we want to subtract 6/10. So I'm going to cross off 6 of the tenths that we started with. And there we go. We are left with 3/10. And that's the difference, the answer to that subtraction problem. On the back side, I can convert metric measurements, larger units to smaller units. Write the rule and complete the conversion table. The rule for converting meters to centimeters is multiply by 100. So I'm going to put that here in my little table. Meters times 100 equals centimeters. And so now I can fill in those missing numbers in the table using that rule. 1 meter times 100 is 100 centimeters. 3 meters times 100 is 300 centimeters. 9 meters times 100 is 900 centimeters. 10 meters times 100 is 1,000 centimeters, which is 1,000. 12 meters times 100 is 1,200 centimeters, the same as 1,200. I understand angles are measured with reference to a 360-degree circle with its center at the common endpoint of 2 rays. A circle measures 360 degrees. If the circle were divided into 3 equal parts, what would be the angle measure of each part? Explain how you know. So here in the circle, I want to make a center. I want to divide that into 3 equal parts. So I'm going to go here. And now I'm saying I have 360 degrees here that I want to equally share among those 3 parts. So that's 360 divided by 3. Now we can model that using a place value chart. 1, tens, hundreds. I have 3 hundreds, 6 tens, and no ones. And I want to divide by 3. So I want to break that into 3 equal groups here. I'm going to say, each one of these groups is going to get 1 of my hundreds. So we'll go just like this. We could say that's 100, 100, and 100. And now for my tens, I want each one of the groups to get a 10. And there's 3 more tens in here, so each group can get another 10. And so now you can see that each one of the sectors in that circle are going to be worth 120 degrees. I can determine the measurement of missing angles. Determine the measure of angle ABD. Well, taking a look at our protractor here, we have a half circle protractor, and BD, ray BD, is lined up with 0 degrees. And as that moves around, as our BA ray is over at, so we're going to increase, so we want to be looking at our bottom numbers here, our inside numbers. We get to 90 here, and then as we continue to look here, we get past 140, right past 150, and it looks like it's right here. So I'd say 154 degrees. It's right before that halfway point, which would be 155. So angle ABD is 154 degrees. That's all for today, math friends.